this problem here, there's actually a fairly simple solution to this, and we can find that without any trig. Well, we are kind of using trig. We can just slice this through here like this, and we can create 6 equilateral triangles that make up this hexagon, regular hexagon. Well, equilateral triangles mean that these sides are all exactly the same. So the diameter of the circle is going to be double this edge length, or 40. Okay. So if we didn't recognize that, we can still use trig by breaking this up into right triangles. So the right triangle that I'm going to use here, and there's lots of ways to split this up into right triangles, but to use symmetry and split it through the middle is the easiest way, because we can generate symmetry and we can find lengths much easier when we do that. Okay, some people may, start chopping it up like this and see if they can get a right triangle, and then, that's not a wrong strategy. However, it is not efficient because it's hard to figure out the lengths of these sides here without a little bit of work. So if we use symmetry and we just slice it through the middle like I did at the beginning, okay, we generate these equilateral triangles, and there's a triangle that I want right there. Okay, and that's really half of that's going to be half of a length. Okay, sorry, half of a equilateral triangle, and the edge length here is going to be exactly half of the edge length here. So if I have this, I know that this is going to be equilateral, or 60 degrees in here. So I'm just going to draw that again. Redraw that, and maybe just draw a little bit more proportionally correct. So this length is 10. There's 60 degrees in here. And really, if I can find one of the side triangle lengths here, okay, that will give me half the diameter. Okay, so that's what I'm looking for. So setting this up, I'm going to use, I want to solve for the hypotenuse. I have the adjacent side. So adjacent hypotenuses are ka, or cosine. So we know that cosine of 60 degrees is equal to the adjacent compared to the hypotenuse. Okay, cosine of 60 degrees from my calculator gives me 0.5. Okay, solving this algebraically, I get my hypotenuse is equal to 20, which is what we kind of expected. We know that that red length is 20. And so the diameter is then double that, which is 40, which we had figured out before. Okay, so like I said, there's a fairly simple solution to that if we understand that we can split this up symmetrically. So in this last problem here, we have a right triangle down here that we can work with, but we have this non-right triangle in here. Okay, and we want to find out the height of the smokestack. Well, if I just split that up, just divide that here, and let's kind of assume that, let's maybe draw this 35 meters to where that observer is at. This length here is 35 meters. Okay, so really all I'm just trying to do is figure out the last little bit of this triangle up here, okay, that I'm kind of highlighting in green. We want to find that, and we'll call that x. So how do I find that out? Well, I kind of don't have enough information here. I know that's going to be 30 meters here, and I have x, but I don't know this angle. But what I'm going to do here is, because I have a right triangle in here in red, that right triangle will allow me to solve for this angle in here. And if I solve for the partial angle, I can figure out the green part of that angle by subtracting from 70. So I'm going to call this angle theta, and I'm going to call this other angle over here alpha or something like that. So I can figure out angle theta because I have two sides of that red triangle. I've got 30 meters and 35. So if I just kind of draw that out, here's theta. The opposite side is 35, and the adjacent side to that is 30. This is tan ratio. So I know that tan theta equals 35 over 30. I need to undo this. I need to go from ratio to angle, so I need to use my arctan function. And that gives me my angle theta. So I'm going to do arctan of 35 divided by 30. That gives me an angle of 49.398, so I'm going to round that to 40 degrees. And so that's going to be 49.40 degrees. Now I can figure out the alpha angle here. So that angle is going to be 90 minus 49.4 degrees. So that angle in here is going to be 40.60 degrees. Okay? And so what I now have then is, I have this green triangle. I need to solve for x. I have the bottom length of 30 meters. And I have the angle as 40.60 degrees. Well, I can solve this triangle for x. I have two sides. I have an angle. The two sides are opposite and adjacent. Okay, again, that's slope. So I'm going to use my tan ratio. So tan of 40.60 degrees is equal to the ratio of opposite over adjacent, okay, or my slope. So what I need then is the slope of that angle. The slope of that angle, so tan of 40.4 degrees, the slope of that angle is 0.851 to 1. Okay? So for my calculator, I've got 0.851, and again, remember the one number ratio is always being compared to 1. Solving algebraically for x, I get 30 times that number, and the height of that triangle is 25.53 meters. So this length here is 25.53 meters. The full height of that stack then is going to be the sum of those two, this 35 and the 25.53. So the smokestack then is going to be equal to 50, oops, sorry, that's going to end up being 60, isn't it? 60.53 meters tall. Okay, so there it is.